Every piece of software you've ever used runs on the same idea. A programmer writes the rules, feeds in data, and the computer spits out answers. Machine learning flips that completely. Instead of writing the rules yourself, you give the computer the data and the answers, and you let it figure out the rules on its own. That shift from hand coding logic to learning it from examples is the entire reason machine learning exists, and it's why it now powers everything from spam filters to fraud detection to the intrusion detection system sitting on your network right now. So how does a machine actually learn from data? There isn't just one way, there are three major approaches, and each one solves a different kind of problem. Supervised learning learns from examples that already have the right answer attached. Unsupervised learning looks at data with no answers at all and finds structure on its own. And reinforcement learning learns by acting, failing, and getting better through trial and error guided by rewards. Understanding when to reach for each of these is one of the most common things interviewers probe for. So let's break down each one, starting with supervised learning. Supervised learning is the most intuitive of the three because it mirrors how a teacher grades homework. You give the model a big pile of examples, and every single example is already labeled with the correct answer. The model looks at thousands of these input-output pairs and gradually adjusts itself until it can predict the right label for an example it has never seen before. The supervision is literally the labels. A human or a labeled dataset is supervising the learning process the whole way through. Here's a concrete example you already use every day: your email spam filter. It was trained on millions of emails that humans had already labeled as spam or not spam. The model studied the patterns, suspicious links, certain phrases, sender behavior, and learned to associate those patterns with the spam label. Now, when a brand new email lands in your inbox, the model applies what it learned and predicts spam or not spam in a fraction of a second. That's supervised learning in production. Unsupervised learning removes the labels entirely. You just hand the model a pile of raw data and ask it, "What structure do you see in here?" There's no right answer to check against. The model has to find patterns, similarities, and groupings completely on its own. The most common outcome is clustering. The model naturally groups similar data points together, even though nobody told it what those groups should represent. It's about discovering something you didn't already know was there. This is huge in security. Imagine you feed a model months of ordinary network traffic, logins, file transfers, data volumes, with no labels for normal or attack. The model clusters all of that traffic based on similarity, and over time it learns what normal looks like. So when a login suddenly happens at 3 a.m. from a country your company has never operated in, that data point falls way outside every existing cluster, and the model flags it as an anomaly. Reinforcement learning works completely differently from the other two. There's no labeled dataset and no static pile of data to cluster. Instead, there's an agent that lives inside an environment, and it learns purely through trial and error. The agent takes an action, the environment responds, and the agent receives a reward or a penalty based on how good that action was. Over thousands or millions of these cycles, the agent gradually learns which actions lead to the best long-term reward. Picture an automated incident response system defending a network. When it detects a suspicious process, it can choose an action, isolate the host, kill the process, or do nothing. Each choice leads to a consequence. Correctly stopping a real attack earns a reward, while wrongly shutting down a critical production server earns a heavy penalty. No one hand-coded the correct response for every scenario. The agent discovered it through reward-driven trial and error. So when do you actually reach for each one? If you have historical data with known outcomes, fraud or not fraud, malware or benign, that's a supervised problem. If you have a mountain of raw data and you're hunting for hidden structure or outliers with no predefined labels, that's unsupervised. And if you're dealing with a system that has to make a sequence of decisions over time, learning from consequences rather than a fixed data set, that's reinforcement learning. Let's bring it all together. Machine learning replaces handwritten rules with rules learned from data. Supervised learning learns from labeled examples like a spam filter. Unsupervised learning finds structure in unlabeled data, like clustering network traffic to spot anomalies. And reinforcement learning learns through trial, error, and reward, like an automated response agent defending a network. These three categories show up constantly in security tooling, so knowing exactly which one applies to a given problem is a skill that will serve you well. If this helped clarify the landscape, subscribe. There's a lot more of this coming.